Basically, I will give an overview about LCA. So we've been also integrating some LCA related stuff within the process within the project. As you might know, basically LCA intends to study all the life cycle stages or along the production of the of, let's say, one of the case studies in this case, and integration of the laser-based technology, and so the idea also is to compare traditional technologies like chemical and mechanical based treatments with the laser-based, let's say, cutting-edge technologies that we have been developing within the SYNTECS project. LCA intends basically to provide an overview on the mission target of the company. So the idea also is to calculate not only reduce the CO2 emission, but also to provide an overview on the, for example, on the KPIs, and so it can be very relevant for reporting and compliance. And another possibility also for the application of ICA is also to calculate the corporate carbon footprint. And of course, we can also achieve some science-based target like net zero standards. That is another very important and widely, most of the clients are goes for this kind of solution also through eco design. So I would like just to introduce which was our approach within the SYNTECS project. Of course, we rely on specific norms. We adopt specific software, which is SIMA Pro, and also a recipe method that is basically we have been focused on specific impact categories. So in this case, we will see that is global warming potential, human toxicity, and mineral resource scarcity. Of course, there is also a specific database, and what we've been doing along the process basically is the structure in the production processes, and so understand everything that is related to material usage, energy consumption, and waste generation mainly. I would like to highlight that also that in along the development of the project, so which started 2023, basically there was a kind of revolution also within the SCA framework. So there were at least 3 stages of the framework that has been affected also by the application of AI agents. Yeah, this is very relevant. And this is something that can speed up the process, and also not only in the very beginning of the process. So let's say in order to fill up any kind of lacunas or gap of data within the process, but also can also be very relevant in the analysis of the data and definition of the boundaries, so analysis also of the results. Concerning the results within the project, as the colleagues already showed previously, we saw that when we compare conventional chemical and mechanical based technologies with the laser-based innovative technologies, we can see that there was a significant improvement of the sustainability of the process. We can see that, for example, in the conventional scenario, that is usually there is also the necessity of an extra treatment, and this is of course improving all the impact categories, so the global warming potential, the human toxicity, and the mineral resource scarcity. And we can see that there is a significant reduction of the emissions, especially when we compare it with the laser treatment associated to the use of recycled plastics. So yeah, we can basically conclude that there was a significant reduction of the emissions, especially when we scale up to, for example, 50,000 cycles, so 50,000 pieces, or in this case plastic parts from injection molding. And we would like to highlight also that the use of secondary raw materials is very important in order to reduce the CO2 emission. We can see also that there can be a reduction up to almost 100% if there was a proper optimization of the production process. Concerning the second case study, which was the EP plant, we saw also in this case that is by the application of laser technology with or without provision of replacement of the EP plant along the life cycle or life services or the in-service life, let's say, of the EP plant, we can see that there is also a significant reduction of CO2 emissions, up to almost 40%. And for sure, there is also an improvement when we compare, for example, let's say that there is not much improvement when we use a laser hybrid approach when compared to traditional conventional technology. However, there are clear benefits of using LST or DPS, for example, technologies, laser-based technology, in order to achieve the required properties of the surfaces. When we skip to the third case study, even in this case, we can see that the laser scenario can provide a reduction of CO2 emission up to 73%. And we can see that the main focus was on the use and maintenance, so on the optimization of the heat transfer. And in general, also the end of life. So due to the less usage of, for example, copper, can reduce up to 50 kilogram of CO2 per piece, so per vapor chamber. And this can lead, of course, not only to a reduction of the emission, not only to a reduction of the use of specific materials like copper, but also a reduction also of human toxicity. So there are several benefits out of it. So basically, I would like to briefly conclude, and to highlight that there was an increased number of companies. There are an increased number of companies that are looking for a compressing LCA rather than a mere carbon footprint. So we need for sure an urgent automation, and this is happening in commercial software nowadays for environmental. Let's say environmental softwares are implementing a lot of those approaches. And on the other side, we see that the laser detection treatment can significantly decrease the environmental impacts. And so, we can see that sustainability. There are benefits out of it by applying those laser-based technologies. And then the last for the implementation within the SYNTECS product was also an integration of LCA data within a CAD software. So basically, the idea was to translate the sustainability related results directly within a CAD software. So for designer, basically. And so now I would like to give floor to Jessica or Diogo in order to go on with this second part of the presentation. And I stop my presentation. Maybe we'll leave floor for at the end for questions, so we can. Thanks.
Thank you, Giovanni.
Hi. So good morning. I'm Jessica. Let me just share my screen. Can you all see my screen?
Yes.
So the first part will be a video demonstrating how the LCA to CAD plugin works. So you can have an understanding of how we get that information from the LCA results into the CAD environment. So first, in this case, we use FreeCAD as a CAD software, and we can import any 3D model pre-existing or create an existing or create a 3D model. And then we import the LCA information that is presented in spreadsheet form. We can import as many LCA information as is required to do comparisons. And then we can check the differences between different factors of the LCA. So in this case, global warming, human carcinogenic toxicity, between two different types of manufacturing. So in this case, the conventional and the laser manufacturing. And then we can also change which types of the cycle we want to visualize. So in this case, it's the all life cycles, surface treatment, and user maintenance and end of life. And that will give us the corresponding graphs to that information. We can also check just surfaces of the model. So, example, if we have a model which has different textures or different materials, we can choose that surface, and then we will see the corresponding LCA results for only that surface with this plugin. As this is a CAD model, we can perform all the operations in a drawing tablet, which is normally where designers work, and they can, while using the CAD software, they can check the LCA factors. We are currently also improving this plugin, and this is one of the possibilities we intend that the plugin has. So a more robust presentation and easier of use by an easier of use interface. So here, as you can see, the users can select what is the production technique, the impact categories, and the life cycle that they want to check, and that would show on the graphs which are presented in the plugin. We are also thinking of aggregating some information to make it easier to see the impact. So in this case, having the full global warming, and then which part of the cycles sorry, forgot the word, corresponds more to that global warming result. And that's all from our side. Any questions, either to Giovanni or to me, we are open.
Thank you, Jessica. Let's see if there is any question. Meanwhile, Giovanni, for you, probably in the lines with the conversation with Niels from Offer, on challenge, basically in developing the LCA tool, it is also data, or there is other challenge that you face basically doing this tool?
Yeah, basically when you scale up to a wide range of application, because we're focused on 3 case studies, but we need to go over. So we need to think about an interoperability of the machine as well. And so it's the same for LCA. So that basically we need to somehow fine-tune every case study manually nowadays. So this is one of the main problems, because it's very time-consuming. So yeah, something that ends up to be very expensive as well. So that's why in order to fill, let's say, the lacuna and the gaps in terms of data. So basically material, energy, and waste most of the time. So we need to build up processes, for example, SIMAPRO, Sfera, that are based on those three main topics. So sometimes it's difficult to get all the data because depends very much on the case study, and so not only the operational condition of the laser but also the final application of the an output of the process. It's something that is very relevant. And then another limitation for sure is the end of life, because there is a, let's say, silos effect of retention of data from the raw materials to the production to the end of life. And so sometimes it's very difficult to get this, let's say, all the data along the life cycle, all the stages of the life of the product. And in this sense, I would like to highlight that there is an improvement by the European Union in this sense, because we know that by 2028, more or less, depending on the technology, depending on the product, there will the digital passport product will be mandatory for commercialization in the European Union. And this might somehow prevent this retention of information, or so at least we know, or everyone can know how the supply chain and so the value chain of the technology of the product itself can be traced back, and so can be valuable for sure for from our point of view, from the LCA point of view, let's say, so the sustainability related aspects. But yes, this is something that there is a lot to do still. There's something that is need to be fine-tuned for sure in many cases. And then there are the other parts, which are the integration of AI agents and LLMs. So all the any types of artificial intelligence that is has been integrating, and this is something very relevant for software developers. And we are trying to go also in this direction actually, in order to fill basically those gaps and speed up the process.
Okay, thank you. A question for Jessica. So regarding the CAD tool and the integration of the LCA. So you were saying that you are planning some kind of updates, and the first question is like when we can have like the final version, at least for the project. It will be more or less at the end. And the second question is, any plans after the project, so to use or to exploit a little bit this integration?
A more robust version of the plugin will be delivered at the end of the SYNTECS project. And for the future, since this is an open source software, we hope that by open sourcing it can also be used by the community to improve it as they see fit. So on this basis, and then improve it with more functionalities or more robustness in getting the LCA information into the plugin.